Effects of electric current. Have you ever wondered why does an electric bulb glow when we switch it on? How does an electric bell ring when we press the calling bell? All these are the effects of electric current. Let's understand how different effects are produced when electric current flows through a wire. Electric current is the flow of electrical charges along a closed circuit. The charges flow whenever there is a difference of potential between the positive and negative terminal of a circuit. This potential difference is provided by a cell, a generator, or power stations. The substances that allow current to pass through them are called conductors. Some metals, such as copper and aluminium, offer very little resistance to the flow of current. They are known to be good conductors of electricity. They are thus used as wires for transmitting electricity in electrical circuits. Some other metals and mixtures of metals offer relatively higher resistance to the flow of current. For example, iron, tungsten, and nichrome. Electrical resistance also depends on the thickness and length of the material. When the metal wire is longer, the resistance is higher. If the wire is thicker, the resistance is lower. The resistance offered by these different metals is what gives rise to the heating effects of electric current. The metal gets heated due to electrical resistance as high electric current flows through it. If it has a low melting point, the metal melts quickly and breaks. If it has a high melting point, then it becomes very hot and glows, producing light and heat. If a short circuit occurs in an appliance, a sudden heavy current flows through the wire. Thus, the wire could easily get overheated due to excess current and burn to rupture its insulation, causing fire. To prevent fire and damage to appliances, an electric fuse is used in electrical circuits and appliances. The filament of the incandescent bulbs and electric heaters is in the shape of a coil. It is made of tungsten or of the alloy nickel and chromium, which offer high resistance to electric flow and melt at a very high temperature. Thus, the filament becomes red hot and starts to glow, producing heat and light. Electrical energy is thus converted to light and heat energy. Apart from heat and light, electric current passing through metal wires also produce other effects. A wire carrying electric current can deflect a compass needle. When the direction of the current is reversed, the needle deflects in opposite direction. The deflection is more when the current is more. We know that a compass needle can only be deflected by a magnet. Thus, it shows that a current-carrying wire also produces a magnetic field around it. To increase the magnetic strength, current is passed through a wire made in the shape of a coil. This coil acts as a bar magnet with the north and south pole at the opposite ends whenever current is passed through it. This is called a solenoid. A coil of insulated wire wound around a piece of magnetic substance called the core acts as a magnet when current is passed through it. This is called an electromagnet. The core increases the magnetic strength by several times. An electric bell works on this principle. It has an electromagnet, an iron piece attached to a hammer at one end and a spring at the other end. When electric current is passed through the electromagnet, it attracts the iron hammer towards itself, causing the hammer to strike the gong and producing sound. At the same time, the end of the iron rod attached to the hammer loses contact and the electric circuit is broken. Current does not flow through the circuit and the electromagnet is turned off. It loses its magnetism and no longer attracts the hammer. Thus, the hammer comes back to its original position. The circuit is closed once again. This cycle repeats itself till the current is switched off.
Subscribe now and press the bell icon. Never miss an update.